If everyone could go ahead and click the OK to recording on their screen, we're going to send it out to all the teams later. So there we go. Okay, so I think let's get started. So thank you everyone for coming. I'm so excited to have everyone here. I know it's a challenging time with everything going on, and I know there's a ton of unknowns, so I'm happy that everyone was able to make it here today. So we're going to start off by having us, the host team 1836, give our presentation. So I'm going to go ahead and present. Okay, so this is our team presentation, and presenters, go ahead and unmute yourself.
So, go ahead, Josh.
All right, so our robot first starts with the 6 high grip wheels on an AMU 14U4 KOP chassis, stock gearboxes with 2 Falcon 500 motors each. In there, the intake, which is pneumatically actuated and has spring 4-bar linkage with 4 rollers that are the full width of the robot and extend over the bumpers to intake balls into the hopper. In that hopper, with a 5-ball capacity, the balls are serialized into the elevator. In the elevator, from the hopper's 5-ball capacity, the elevator is able to preload 3 balls, and a pneumatically actuated release occurs to allow shots. In the elevator, HDD timing belts physically raise balls into the chute. Once under the shooter, 2 Neo motors power a 6-inch flywheel geared in a 1:5 ratio with 1.75 inches of ball compression. 1 to 2 inertial mass manufactured in-house keeps it up for rapid fire shots. And via shooter velocity, hood angle, and an average speed of height, the robot is able to fully optimize each of its shots. Once the balls are in rapid fire shots, and via shooter velocity, hood angle, fully optimize each of its shots. Once the shooting phase is done, it is done with cylinders with routed metal hooks, as well as being a magnet. To control it, cylinder actuation reaches the magnets and stretches surgical tubing to lift the hooks high enough to latch onto the hanging bar.
So our robot, if your internet connection is laggy and if you couldn't hear, our robot is a kitbot with our intake is a full width of the robot. It is 4 rollers, and it worked very well in competition. We were very happy with it. Our shooter, which was one of our more ambitious things that we did this year, had a 2-to-1 inertial mass. So instead of having to have so much weight at the top of the robot, our inertial mass is half the weight of the inertia that it produces, because it's geared to spin at double the speed of our 6-inch flywheel. And another thing that was interesting that we made the decision to do was, instead of using sensors to hold our balls in the elevator, we had these pneumatic actuators that stop balls and used a system which held 3 balls in place without them getting caught on each other.
So I'm one of the 3 coders on our team, and so our auto used we use switch states in a shuffleboard to determine which auto we would use, basically allowing us to click where placed center, right, or left side, and from there our robot would automatically use sequential commands when the match starts to do our general auto. Our auto this year consisted of, for the most part, just driving forward or backwards and then shooting all 3 balls in our hopper, as well as we had I believe, right side auto that would go pick up 2 balls, drive back to the target, auto aim, and start firing all balls. Our teleop, we used a custom arcade drive, and we had a lot of tipping because our robot was so tall this year. So we ramped our motor speed so that when we let go, we wouldn't have that brake mode, but we also didn't have a full coast. So we'd kind of stop slowly. We wanted to simplify the commands for both our operator and driver. So we have a one button intake mode, which extends our intake, starts running our elevator to preload balls and reduces the drive speed and turn speed so that we can aim correctly. As soon as we pick up all our balls, our operator clicks another button and the intake is retracted, elevator speed is stopped, and we allow full drive speed again to be able to get to our position. When we get to our desired position, our driver and operator each have their own button that once they hold down, activates our limelight, which will angle our robot straight onto the target. From there, we will use our distance to adjust our RPM and hood position of our shooter. And once we reach those target RPMs and hood position with a little bit of error, we will retract our pneumatic stopper, which will allow balls to flow up through the elevator and start shooting. Everything is automated, so both the driver and operator only need to click one button. And we use interpolation to determine the position, or to determine the RPM and hood position. So that means we basically have a set of somewhere between, I think it's like 30 to 50 points based on our distance. And from that, we get the average in between the closest points based off our distance. And that tells us our hood position RPM.
Great, so here is a quick video of our 5 3-pointers.
All of that was using Limelight and no human interaction, I guess.
Yeah. Okay, so for this year for our scouting, we used an HTML form that was linked to a Google Sheet. So here's an example of the lookup. And we also used a TBA scraper to get data from TBA. So it automatically provided us with the team name, and it gave a picture of a robot if like applied. So it gives averages, but we didn't have enough data, for example, because we didn't do ourselves, but it gave different stages. So that was our scouting for this year. For the business side, we've rebranded. We have a new logo now, and we also created a brochure to give out at competitions, which we haven't really done in the past. So that's our team. Does anyone have any questions for Team 1836 about our robot? If you have any questions, you can use the raise hand feature at the bottom of your screen. It says participants, and then we will call on you. We'll invite you to unmute yourselves.
To answer the question in the chat about jamming, we had a couple of times little jamming issues, but nothing that couldn't be solved by just reversing the elevator for a split second, and then all the balls were able to flow smoothly. We actually ended up taking out the wheeled mechanism that actually was active on the hopper and ended up just using gravity, and that worked a lot better for us.
Okay, so now we'd like to invite GAL Tech Innovators Team 3535 to share their screen and give their presentation.
Hey guys, it'll be just a second. In the background, we've got some people working on a floor, so you might hear a little feedback there. Okay. So, first of all, the team is Galactic Invaders, and we were originally a Lapeer team. We took over a North Branch team towards the end of last year, and now are completely located in North Branch, but none of our stuff is set up to show that yet. So we did actually compete at Kettering 1, and I'll show some videos of that in a moment. But yeah, just a basic PowerPoint that we put together to show some of the stuff. So this is our robot at the build site. We actually have 3 classrooms in North Branch that are set up for us. So this particular room is just our practice room for driving the robot around and doing whatever we need with the robot. This picture, as you can see, is at Kettering. This is our pit setup. And this is probably one of the better slides as far as showing our robot. I didn't provide a whole lot of great detail like the host team. So let me see. Yeah, thanks. The team member that's actually here with me is my son. He's the one that created that logo for this year. We typically have this Invader logo, but he superimposed Star Wars on this one, so that was quite fun. Back to the robots, we've got an intake here and what we called an uptake or an elevator for bringing the balls up to the shooter that's right here. And just scream at me in the chat if you guys can't see my mouse moving around. But I'll let Thomas explain some of this because he's the one that helped build and test a lot of this intake, uptake, and the shooter. So he can explain some things a little bit more detail there.
So I was actually the operator or the second controller of the robot. And in doing that, I would have to, of course, control the uptake, which is what we called the elevator, and going up and down, and then we would take the, what would that be? I also controlled the intake up and down. We kept having like jamming issues as far as it coming in and then stopping at the corners, and we had to put in some do you think that's plexiglass?
Yeah, it's plexiglass on the side that you can barely see it here. It's plexiglass on the side to hold the balls. And then we put some specialized printed, 3D printed Omni wheels you can barely see here. But these helped to direction the ball towards the uptake. So as it would come in the intake, it would slide into a bent plexiglass here into the uptake to bring it in here. Now, did you want to talk about these rollers or did you want me to?
You go ahead.
Okay. So you may or may not be able to see very clearly on these, but each of these rollers are independently driven. They are, I guess they're all belt driven, but they were engineered a way that if we have multiple balls in here, this one will keep spinning, but won't continue to push the ball up while we're trying to bring more balls in. So that turned out to be very helpful at Kettering, so that we weren't completely jamming the balls up to the shooter, that we could continue to stage balls in. I'm gonna go through a couple more pictures here. This is our build room, traditional size classroom that they allowed us to do whatever we wanted with it. Okay, 30 seconds remaining, thank you. So I'll just cycle through these. And if you follow us on Instagram, you're probably already going to see a lot of these pictures. So won't waste a whole lot of time going through the pictures. We did end up getting second place at Kettering 1. This is one of the 6 robot climbs that happened at Kettering. This is us with our industrial design award for that uptake. This is the full alliance that won second place at Kettering with our awards. And I'll exit this, and I'm going to show our Auton. So it would drive up, shoot the 3 balls at the beginning. That's what our Auton would do. Towards the end, we had an Auton that was, that's not my other Auton. We had another Auton that would shoot the 3 balls, drive off the line, and turn towards the control panel. So we could pick up more balls when it came to teleop. This happens to be one of the videos of our climbing. So the whole alliance climbing up. We've got a whole lot of videos and pictures on our social media, and more than welcome to answer any questions later. But that's what we've got for our team this year. We were hoping to go for another win, but as everybody else here knows, we didn't get that chance.
Perfect. Thank you so much for presenting. Your robot seemed really cool. We had 2 questions in the chat. So the first one was from Team 67 from Alyssa. She asked, what drivetrain wheels are you running? Why did you choose that configuration? So go ahead and answer.
Yeah, so the drivetrain that we ran with 4 Venom motors that had built-in controllers. It was a total of 6 wheels, arcade drive, kind of a specialized arcade drive. But the 6-wheel arcade drive with Venom motors. Why we chose that? With the Venom motors, they have a built-in encoder. So it was literally just call to the class in Java and say, get encoder count, drive to this encoder count, and it was literally 2 or 3 lines of code.
Great. The next question was, did you experience any tipping?
Towards the beginning, yes. There was some tipping. We were working on an arm that we were planning on using in our second competition that another team we saw at Kettering had something similar. Instead of just hooks that would grab onto the bar, it was a motorized arm. So as we got onto the bar, we could drive on the bar itself to move back and forth on the arm so we wouldn't slide all the way down. But initially when we started climbing, we would have some tipping there.
Okay, we're going to take these 2 last questions and then we're going to wrap up. Was that a Venom motor, someone asked?
Yes, we had a total of 5 Venom motors on our robot, 4 for driving, and then 1 for the shooter. The shooter used a specialized Venom PID loop. Again, we chose Venom because the code was just very painless. It was about 6 lines of code, give or take, to do the PID loop.
Great. And then the last question was, how did you design your elevator to slip?
That'd be easier to discuss at a later point. If you want to reach out to us after this.
Message them, that'd be great.
Yeah.
Thank you so much. That was great. I'm going to go ahead now and share the presentation order, which I forgot to do at the beginning. So it was Galtech just went, they did a great job, and then it's going to be 2491, 4967, 2706, 6404, 4319, 34, 1511, 7439, 862, 2638, 5577, 5943, 4909, 1117, 4188, 1684, 3566, wasn't sure if they were able to come, 67, 1758, and 3322. So I'm going to go ahead and now invite 2491 to please share their screen.
Hello. There we go. Okay. Kate, you want to start?
Yeah. Hi, I'm Kate. I'm the team captain of 2491 No Mythic, and this is a bit about our 2020 robot. So for a robot strategy, realize that after looking at the game, we realized that the fastest cycles were going to be picking up balls at the feeder station and then driving under the control panel and then shooting from the close side of the trench. We did this so we'd be shooting from inside a safe zone. We realized climbing would be important not only for the end game points, but also for rank points. And with that strategy, we created Clank. Clank competed in the Minnesota North Star competition, and now my teammates will tell you how it works.
Hi, so I'm Wesley. I was the team captain for this last season, but I'm a senior, so I'm out of here now. So our drivetrain was nothing too fancy. Pretty much we just looked at the game and realized what we wanted our drivetrain to do was be able to drive fast so we can get fast cycles and then be able to go over the little bumps in the middle of the field smoothly in case there's another team running under the trench. So what we ended up settling on was 8-wheel tank drive. We used Colson's this year. The other thing that we did this year was we tried out the new Falcons. We actually really liked how those Falcons worked. They seemed pretty seamless and things seemed to work out well with that. Another thing that we did this year is we just used one big belt for the whole drivetrain. In the past, we'd used 2 belts, but we had issues with them rubbing on each other and breaking. So when we switched to this belt, our belt worked really well this year. We didn't actually break any. The other thing that we have on here that we'll talk about a little bit later on is we have a PTO on our drivetrain, so we can shift over, so we can shift onto our climb. But we'll touch on that when we talk about the climb later on.
All right. Hi, I'm Lando. I was the design captain on the team. So I'm going to talk about our index and intake system. So we have our intake, which actuates on a virtual 4-bar, as you can see there, which allowed us to package it really nice in like a small area on the front of our robot. And then we had a 4-roller design, one of them springing out of the way so that the ball maintained a pretty equal compression throughout its travel over the bumper. And so, yeah, that ended up working really well. So as soon as you would touch a ball, they would immediately go right in. And then for the indexer, we have just one belt that kind of loops the whole thing with a ramp on the other side of it. So it kind of went in like the C motion through the robot and then out the shooter. And then since our intake was full width, we needed a way to funnel the balls into the indexer into a straight line. So we have a V-shaped belt system, which is kind of just runs, each belt runs at a different speed, which helps to reduce the jamming as it goes through that. So as soon as it would touch one of those, it would just get sucked right into the indexer. So that all worked really well for us.
All right, so I'm going to talk a little bit about the shooter as well. So after the balls come out of the indexer, they'll go into our shooter, and our shooter is pretty straightforward. It's just a single flywheel system with one 4-inch Fairlane wheel. And then we have these 2 big metal flywheels on the sides. Each of those are, I think, 4 inches in diameter, and they weigh 5 pounds each. So it's a total of 10 pounds. And we would, the 10 pounds along with a PID loop on our shooter motor. Shooter motors allowed us just to get a really consistent shot. And so that combined with, so basically for our shooter design, we chose to go very simple, and we just have a fixed position hood, and we can adjust our RPM to shoot from, to shoot from 3 different locations. And that has really helped us get a pretty consistent shot. We're usually making 4 to 5 out of 5 shots in a cycle. And that really so we pretty much just wanted to be really simple and very consistent. And that approach seemed to really work out for us. If we had more time, we wanted to switch over to having adjustable hood and vision, but we didn't. So we just used the flashlight to line up.
Hi, I'm the production captain on Nomadic and was the driver this year as well.
You guys have 15 seconds remaining.
Okay. So our climber, it extends on a single telescoping arm with constant force springs, as you can see there. And then that places a single hook on the bar, which we then use the PTO system that Wesley was talking about from before to spool up motors, picking up string from 4 corners of the robot, as you can see there. And we also have piston brakes on the spools, and that allowed for a very consistent climb. And then it allowed us at our competition to seed first, and then going on to pick night crawlers, which synced really well with our strategy. And then ended up going on to win a large part to our climbing and consistent strategy. Questions?
Hi. Okay. Sorry to interrupt. We're actually, thank you for going. Sorry for interrupting. We want
Very good.
people to go and have this be as short as possible because our next showcase to get to. So we're going to move all questions to the end. So if you have a question, you can write it down and just save it till the end. So thank you for presenting. That was really good. We're going to move on to 4967, that one team. So if you could go ahead and share your screen, that'd be great. Great, thank you.
Hi, I'm Luke.
I'm Anna.
And I'm Bridget.
And we are Team 4967, that one team, our next engineers.
So Hydro and Hooky is our robot. Hydro would be the name of the robot, and Hooky is the name of our hook. We have an intake in the front that can pick up at the floor and also at the loading zone. A hopper in the middle that sorts the balls. The shooter in the back, it has 2 Coulsons and 2 Neos that run them. What we call a 2-step climber. There is a fish hook that gets deployed on the bar that deploys the hook that gets hooked onto the bar, and then a ratchet that's in the middle back of our robot that'll pull us up. Once we're hooked on, it takes about 5 seconds to get to the top of the bar, and a spotlight that helps us line up for shots. Oh, and here is a video of our robot in action.
So here's the one event that we went to. It was the Georgian College District event. It was from March 6th to March 8th, so it was a week 2 event. We ended up ranking 3rd with a record of 12-5 in the event. It was a lot of fun, and we're very happy we got to go, especially since the rest of our events were postponed.
So keeping up team spirit's a very difficult thing to do during these trying times. So one way we've worked around that is through our constant video calls with the team, making sure we're keeping things going while all this is going on. And that's what you can see on that second picture there. And that first picture is our mascot, Puddle. Very happy to be at our first Gambit competition.
We can get any teams completing the auto quest.
Sorry.
So a few of our team goals for this year were to rank
For our Red Alliance, the Gearheads.
So a few of our team goals this year. Oh, go ahead. Okay, our team goals for the year were to rank in the top 13%, to earn an award we are yet to receive, be an alliance captain or first pick at every event, earn a spot at states and win our division, and earn a spot at the World Championships.
So a few of the awards that we hope to win were the Team Spirit Award, the Chairmanship Award, the Gracious Professionalism Award, and the Entrepreneurship Award.
So right during the COVID-19 crisis, we've been trying to help out as best we can. So we have been making masks for businesses that need them around us. And we've also been 3D printing ear savers and face shield bands.
So our team is really big on community outreach. And one big thing we do is we have a summer camp for young students so they can learn more about robotics through LEGO Mindstorms, as well as fun science projects that they get to participate and view. And they have a ton of fun with that. Also, we do some environmental service, and we clean out our local rivers with the Rogue River cleanup event and the Grand River cleanup event. And in those pictures, you could see some of the treasures we found during our environmental cleanups.
Thank you for listening to our presentation.
Perfect. Thank you so much. That was really great. Your team is helping out during this COVID-19 time. Next is 2706, Merge Robotics. If you could go ahead and share your screen, that'd be great.
So it's not letting me share my screen.
If you click at the bottom of the screen, the little green share screen, it's enabled for all.
Yeah, but the screen that I want to share isn't on. Let me try this.
You start sharing your screen.
Can you see that?
Yeah.
Okay. So I'm just going to start with a little introduction. So I'm from Team 2706, Merge Robotics. We are a team from Ontario, Canada, and we're also a community team. And so here we want to just highlight our safety mascot, Shep. And a lot of people have been asking about his backstory, and so this is his backstory.
I'm sorry to interrupt, but we're unable to see it. Or
you can't see it?
No, we don't. We just see your screen that says PC downloads.
Huh. Okay. Well, the video is just a bunch of pictures, so you can just listen to the recording. It'll be okay.
Hi, so we can't hear it. Maybe you could turn up the volume. There should be a way to share your screen with a different and focus on the video part of it.
It's
As well, when you click share your screen and you're choosing the screen to share, in the bottom left corner it says share computer sound, and that way we can actually hear the video.
Okay. Are you guys okay with just listening to the video, because it won't let me share the actual video, if that makes sense? Is the audio working well?
No, sorry, but we're still unable to hear it clearly.
Okay, well, our team plans on posting the video to YouTube later, so if you guys want to go check that out later. Also, you can follow Shep on his Instagram and stuff there at Shep the Safety Sheep, as well as our team Merge Robotics 2706 on Instagram and Twitter. So yeah, Shep is just basically our safety mascot, and he helps keep teams motivated, as well as our team and other teams at competitions. He promotes safety a lot, especially in times like this. Our team has also been doing a lot of outreach activities from our own homes, of course, such as making masks. We held a sewing outreach initiative where we videotaped a seminar on how to sew masks and things like that. So yeah, that's basically what our team's been up to since the COVID-19 pandemic situation has happened.
Great, thank you for all your team's doing to help. We all think it's great. I'm sorry you weren't able to share. Maybe you could drop your team's YouTube channel link into the chat. That'd be great. So we can all see it later. Next up, we have Team 6404, Brazilian Storm. They said they were having some trouble joining. If you're here, you can go ahead and present.
Can everyone see me?
Yes, we can see perfect.
Okay, so we haven't had much time to make the presentation, and so we are just going to show our robot review video. If you really have any questions, I will come and answer in the chat later. Okay. Let's.
I came from the mud, there's dirt on my hands. Strong like a tree, there's roots where I stand. Oh, I've been running from the law. Hope they won't shoot me down soon. They see on a sleepless night. Try to catch me howling at the moon.
Okay, so this is it. I know it's not very much, but we don't have it. We don't have enough time to prepare something. But if you have any questions, please let me know. I will answer them.
Great, thank you so much, 6404. Your video was really cool. I don't think we have anyone from 4319. So we're gonna go, if you're here. No one's here from 4319, and no one's here from Team 34 Rockets. So we're gonna go ahead and move on to Team 1511, Rolling Thunder. So if you could go ahead and present your screen.
Alrighty, can you all hear me okay?
Yes, perfect.
Alrighty. Nicole, are you ready?
Yep.
Hi, I'm Elliot.
And I'm Nicole.
We are from Team 1511 Rolling Thunder, and we are excited to talk to you about our season. Is it going to switch? There it is.
So this year, our robot was titled Darth Thunderous the Wise. It was a tall robot that shot into the upper port and climbed just about every match. So for this year's drive base, we decided on a 6-wheel drivetrain, which had 4 Omni wheels and 2 traction wheels, with the 4 Omni wheels in each corner and then 2 traction in the center. They were both 6 inches and were driven by 4 Neo brushless motors. Our drive base traveled at about 15.5 feet per second this year. We drive with 2 Xbox controllers and a control system that was custom designed by students and modeled after the Death Star controls. And we program with C++. Now onto our intake and storage. For our intake, we had a beater bar with 2 rollers, one with rubber and one with mecanum wheels that led to a slot in our drive base. This fed into our 5-ball helix mechanism. It had a brush in the center and was driven by a Neo 550, which led up to our shooter. Our shooter was an adjustable hooded turret and had a primer wheel driven by a Neo 550 and a Fairlane shooter wheel driven by a brushless Neo. It also had Limelight on it, but we were never able to use it in a competition, and a 3D printed turret. Next, on to our control panel mechanism. Though we never got to use it, it was 2 4-inch compliance wheels with a Neo 550 and a color sensor. And what made it special was that it was on a flexible mount, which made aligning up to the control panel a lot easier. Next, on to our hang mechanism. So this was 2 3-stage telescoping arms that were attached across the top, which featured 2 student-designed and 3D printed hooks. It was driven by constant force springs and a winch in the back, which used a Neo brushless motor. It also had a ratchet and pawl brake and self-orienting mechanisms at the top and at the base, which allowed us to be level with the floor every match.
We were lucky enough to be able to compete at a Week 1 competition in Miami Valley, Ohio. We had an overall rank of 28th with a record of 5-6-0. We were on the 6-seed alliance with teams 46-11 and 32-1. We were also lucky enough to receive the Chairman's Award at this competition. On the left, you'll see our 3 Chairman's presenters, Adrian, Sage, and myself. This year, our Chairman's video had a spy theme and was led, directed, and shot by a student.
So despite the season being over, we haven't stopped spreading FIRST in our community. We've been making robots we call Weekend Robot videos, which are videos encouraging students of young ages to learn about STEM topics through short videos on our YouTube channel.
Since our competitions have been canceled, we decided to 3D print face shields for medical workers, as well as mask hooks, which help reduce pain on the ears from mask straps. We also deliver food to hospitals. Students from our team have made trivia questions for a citywide Kahoot game, which we played.
Thank you so much for letting us share our season with you. We have social media and a YouTube channel as well as a website if you want to learn more about our team or get in contact with us.
Thank you.
That was great, Team 1511. If anyone has any questions for them, make sure to put it in the chat, and at the end of the session, you can have time to answer. Next up, we have Team 7439, Qubit Robotics. Go ahead and share your screen.
So is everyone able to see my screen?
Yes, we can see it perfectly. Go ahead.
Hi, I'm SG, and I'm going to introduce our team, and after that my friends are going to explain our robot and some of our projects. We are a team from Istanbul, Turkey, and we are Qubit Robotics. This is our 2nd year as a FIRST team, and since now we have participated in 2 regional competition and 2 off-season events. Yeah, I think you can go ahead, Ushin.
So this is our robot for the 2020 season Bosphorus seasonal competition. And this season we have went for the 2 tasks, which is one shooting and the other one is hanging. So for our shooting system, we decided to use a system which is compact and doesn't take much space. With this system, you can both do the intake and the shooting, because this system can actually rotate and shoot the ball outwards. So at first we decided to use this system as plexiglass, but there was a problem occurred. Because of the friction, we couldn't take the balls in, so we went on and made a belt system, which is powered by a snowblower motor, and with this sensor, every ball comes in and travels up a certain amount of distance that they don't get thrown out. And when you have enough balls stacked, we turn the mechanism upwards and shoot to the upper section. And for the climbing, we went on with a pneumatic system, used 2 pistons, and this part is actually a rotating part. We did this because we wanted to make the robot smaller to fit in the limit. And this is connected to a fixed point at the robot. And when the system rises, this actually rises too and clips onto the thing.
We can watch some videos. This is our
This is our shooting system
mechanism. We use color sensor for detect the balls. It's doing storage autonomously. We can pass other video.
So this is a match video of ours in this season. Sorry, are you having any problems hearing the audio?
We didn't hear the audio, but we can see the video perfectly.
Oh, okay, that's fine. So you can observe our climbing mechanism here. So we would like to tell you about one of our initiatives, nature-friendly initiative, since we have limited time. So let's play the video. So in this project of ours, we wanted to give something to the nature too. What we are doing in this project is we are building individual plastic recycling centers that people can bring their own plastics they themselves gather and make recycling on their own. What we are aiming by this is people will understand the value of plastics, and that way they won't throw them away like waste or garbage. So this is a project started by Dave Hackens in a foreign country. So we wanted to be the first ones making this in Turkey. We know that this is a widespread community amongst the world, but there wasn't any individual plastic recycling centers in Turkey. So we are working on opening the first one. Sorry.
We can pass
problem.
Other
Okay.
page.
This was a shootage from Portugal, which we went last year and got the education to make the center in Turkey. And this is the first Precious Plastics community, which is a community we started because we think that Precious Plastics and First Teams have a lot in common, and they are both futures engineers. So we wanted to bring these two communities together and open the first Precious Plastics Instagram page, and have been inviting people to attend this community. So what we wanted.
Oh, sorry, interrupted.
No problem.
Please join our community, and we want to join these two communities because their aims are common. We think we want to share this with you. If you find us in Instagram, we will be very happy.
So okay, that's it for this slide. And thank you for listening us. If you have any questions or something, we can.
And thanks for inviting us.
Great, thank you so much for presenting. We put the link in the chat to follow your plastic initiative, and Talia is going to take it over from here. Talia.
Yes, so the next team will be 862 Lightning Robotics. Please share your screen.
Testing. Can you guys hear me all right?
Yeah.
Yes.
Oh. All right. Slides appearing okay?
Yes, everything's good.
All right. So my name is Nick Lipchick. I was the Vice President of Engineering Operations for the 2020 season, and I'm here to talk to you guys about 862's 2020 robot. So here's a general overview of it. We went for a tall bot. The only reason we didn't go for a short bot is just honestly, we as a team struggle with packaging a little bit. So we wanted to spend that time we would have spent packaging a short bot, iterating our mechanisms, and making sure we can do our job well. So final weigh-in of 122 pounds, cutting it a bit close, 44 inches tall, and then 32 by 27 inch base. Just because we've been burnt by the tolerance gods before, we wanted to make sure we weren't 0.1 of an inch over frame perimeter by trying to go exact. So here's our drivetrain. It's your standard West Coast 3 Neo drive, Vex Pro single stage gearboxes, nothing special there. 2 Omnis in the front, 4 traction in the back for handling, 13.5 feet per second. Something we did that we didn't actually see a lot of other teams do is at the start of the season, we ran our drivetrains over the boundary bars or something like them a lot and found that wheel wear was a big concern, especially with the Omnis. So we put skateboard wheels on dead axles in front of every outbound wheel so they would absorb the brunt of the impact so we wouldn't have to change our wheels out every match. Our intake, we went with a standard CD7 style intake, a belted intake. This was by far the most iterated subsystem on our robot. I think Mark V was the one that ended up on our Jackson robot. 2 775s power it, one that powers the singulating runs and one that powers the ones that actually bring it into the robot. And it's counterbalanced by surgical tubing to let it kick up whenever it intakes a power cell. So here's a video of it in action. This is a robot without a head, so it was pretty early on in the season. Disregard that. Yeah, so really happy with how that turned out. The singulating intake really allowed us to focus on a linear indexer and not spend too much effort into an open hopper. So speaking of that indexer, we did a linear polychord indexer. It stores 5 power cells, and the reason I say it like that is about a week before Jackson, we figured out that putting a 5th ball in there actually jammed up the whole system pretty bad, and we had to make a choice of whether we wanted to R&D ways to fix that for Jackson or just accept that as a limitation and roll with it. So we decided 4 power cells wasn't the biggest limitation in the world and just focused on shooting 4 for Jackson. The indexer only ran when a proximity sensor inside the drive rail was triggered so we wouldn't jam up balls like that. And we had a safety mechanism on top of the robot to prevent balls from prematurely entering the shooter before we were ready. And then here's our shooter, one of the weirder parts of our robot. So it uses 3 traction wheels to fire power cells, spaced 120 degrees apart. Slots in the shooter plates allowed us to adjust wheel compression on the fly and tune it to what we wanted. And it was angled by a lead screw powered by a Johnson Electric PLG motor to give us that angular adjustability. The reason we went with a shooter design like this is we found out that the 3 wheels actually centered the ball as it was firing out and gave us a much more consistent shot overall. It dealt with different ball qualities a lot better than a single flywheel. And then the climber is kind of our panic mechanism because we had a really intricate design where a whole winch went throughout the robot. We could power both stilts off one motor, but we had to bail on that only a week and a half before Jackson and redesign this one from scratch. So both climber stilts are constantly sprung up with shock cording. So when the winch unwinds, the stilts go up, and then we just wind back in that Dyneema cabling to climb. And that brings us to our Jackson competition. So we did pretty well throughout qualifications, fought off some indexer gremlins, but ended up ranking 4th with an overall 8-4 record. We got scooped up by the first seed, Bedford Express, along with Panther Powered for our 3rd pick, and then a clean 6-0 sweep through eliminations to win the event. Alongside that, our business team did phenomenally and got us the entrepreneurship for the 11th year in a row, so keeping that streak alive. And then it says questions, but you guys have made clear you'd like those to wait, so that's all I've got for you.
Okay, thank you so much. So our next team is 2638 Rebel Robotics. You can please present your screen.
All right, can you guys see everything all right?
Yes.
Okay. Yep, so we are Rebel Robotics Team 263. My name is Reed.
I'm Sabrina, and before we start, Team 268 would just like to thank all the first responders out there working and risking their lives right now for everyone who's battling this virus, because we are in New York, just outside New York City, which is the epicenter of the pandemic. And we wanted to just give a big thank you to all of those who are responding to this, and especially to the parents of some of our team members who are on the front line right now. So we'd like to thank them.
Yeah, so who are we? We are Rebel Robotics. We're from Great Neck South High School in Great Neck, New York. We're about 30 minutes from New York City. Fun fact, if you've ever read The Great Gatsby, we are considered the West Egg in that book. This is our 13th season on FRC. Team members represent over 34 different countries. We mentor 10 other teams across other FIRST programs. We've raised over $100,000 for charity over the past 13 years, 1,200% member increase since 2008, and really the main focus and foundation of our team has always been our emphasis on safety. So here's our 2020 robot right here. Here's a picture of it in real life and a CAD photo. So we have an intake right here. The whole thing is driven by West Coast Drive with Falcon 500s. We have control panel spinner right here, a shooter mechanism, a hopper where the power cells go in, and then a climber and hook piston mechanism, so that's how we climb, and then a winch system right here, which lifts up the robot.
So our intakes, where the power cells enter, has 2 shafts with 6 nitro rough top treads that run with the belts, and we also have 2 pistons that attach to our intake that will lift up and maneuver our intake. And this also has a bag motor. And then from the intake, the power cells funnel into our hopper, where we have a conveyor belt-like system with an agitator wheel on the side wall of our hopper, just to allow for fluidity of the balls to get to our shooter. And once we're at the shooter, we have our 2 Coulson wheels and our 2 accelerator wheels, and it did remain in the side panels did remain in wood this year because we weren't able to finalize this, but our new shooter would have had aluminum walls, and it would have been adjustable with if we did get to finalize it.
Yep, so now for our climber, so we have multi-stage pistons, they extend and retract, and the hook grabs on the bar. So once the hook grabs on the bar, this little plate here is attached with Velcro to the hook, so the Velcro breaks and the hook's detached from the pistons. And then there's a rope that's attached to the hooks, and then this winch on the top of the robot with this little yo-yo looking mechanism that essentially pulls the robot up. So you'll see in a video we'll show in a couple minutes. Here is our control panel spinner. It's pretty simple. You can't see it here, but there are plates on either side of these aluminum plates that attach to the robot. So when this piston actuates, the control panel spinner essentially goes from the rest position to the position where it can move the control panel. So here are some videos of our robot in action. You can see the intake right here. And here's the climber pistons. And then the control panel spinner. And here's a video of our robot climbing. And here is a video of the shooter. And last but not least, the intake. This is from a prototype, basically the intaking the balls here. So these are unfortunately all the videos we have since we weren't able to compete in any competitions. All of our competitions got canceled. So yeah, you know, hopefully next year we can compete again. So also the other thing that we pioneered this year was creating a scouting app. So it's a cross-platform app from iOS and Android. We have posted this, I believe, on Chief Delphi at some point. And it is basically an app where you can click different things. So if the robot, let's say, completes the rotation part, you click that. If they go under the trench zone, you can click that, and you can keep track of how many balls they shoot and things like that. And then finally, at the end, there's this button, Save and Export, and that'll export it to a CSV file where you can do further analysis with the scouting data.
And just to go over a little bit of the outreach that we've done, we hosted an FTC event this year, and we also hosted Hour of Code at our middle school for 6th, 7th, and 8th graders. And one of our students collected supplies through our team and throughout our school to distribute to schools and hospitals in India. And also with the Australian wildfires going on, and we decided to adopt a koala and just help him get through recovery. And also mental health became a big initiative this year on our team, and we just really wanted to focus on that. So we promoted that through our school with posters throughout our school, and we involved our school by handing out ribbons on Suicide Prevention Awareness Month, and also necklaces, and our whole team is CPR and AED certified. And we also had a mental health presentation after taking a survey of how our team responds during competitions, and just this was our way of letting them know like how to improve your mental health, and that was something new we added this year.
Yeah, and also one last thing, here's something fun that we did during this time when we're all home. One of our team traditions over the past 13 years is singing Country Roads by John Denver on the bus ride to competitions, but you know, unfortunately we weren't able to do that this year. So instead we created a video where many of our team members and also some alumni recorded themselves singing different lines, and we put it all together into a video. So here's the link in case anyone's interested. And yeah, that's basically it. We will upload this presentation here in case you want to look at it for later. So yeah.
Thank you.
Also email the presentation to us. Everyone will ask everyone to email their presentation.
Okay. All right. Sounds good.
Okay, it doesn't look like we have any questions, but thank you for presenting. The next team is 5577 Kinematic Wolves. Please present.
Hello, we're the Kinematic Wolves from Detroit, Michigan. Our school is Detroit Christian Ray Our school has a unique work study program that allows us to work and learn while we learn and be trained by many of which are sponsors, are the companies that sponsor us. Since our team is funded mainly by companies, and that gives us an opportunity to learn and train with them, and gives us 4 years of experience after we graduate high school. Something else is that we also promote the STEM pipeline, which we first start off with middle school, which we learn, grow, and then we go on to the high school level, which we learn, grow, work, because we got the corporate work study program, and then also go back and mentor level teams. Another thing we do is after the work study program and growing and mentoring, our students go on to college and mainly come back, also continue on the pipeline, learn, grow, train, and then also mentor. Now they are available to mentor all levels of work. And then we have some few alumni who have graduated already college and mostly have stuck with their corporate work study job since they were in high school. And our team is 35 students. 35 students, 11 mentors, and 1 team. Our team is 97% minorities. Our team is also 10% of the school population. And our team is also 38%, which is higher than the national average of 11% in girls in STEM careers. Our quote we stand by is, "Alone we could do so little, and together we can do so much." Shows our community outreach. Something that the main events we do for the community is the Miracle on Burner, which is a Christmas event for the community in which we showcase our robot and also provide STEM activities. The second one is the rainwater collection systems, in which we work in the summer at our local community garden, which is also our founding sponsor is the owners of the garden, which gives it out to the community, and we step in and create water collection systems. Another thing is a Beacon Park. It's a sponsor event in which we go a week before World Championships begin to promote birth. Another thing that we just began is shield donations. We are 3D printing shields for healthcare providers. So far, we've donated to Beaumont, our founding sponsors, since they are still open, the Idea Group, and a community center by us.
Okay, so we also had work done in the robotics community. So we've hosted and assisted FTC workshops and competitions. So through that, we help and mentor other teams, including FTC teams. Through some workshops, we have inspired new FTC teams, and we have helped start new teams in general. We've attended a DTE Expo where we were able to showcase our robot and possibly get new sponsorships. We've also attended a VIP night where our build center is, which is called Detroit Hispanic Development Center. And through there, we work with other robot teams and communicate with other robot teams. There, we also work, we were one of the founding teams for that build center. And a new initiative that we have is that we're teaming up with other robotics FRC teams, including Frog Force, to oversee all FTC and FLL teams in the city of Detroit through a program called Motor City Alliance. So we've also attended off-season events like Kettering and Bloomfield All-Girls Competition. And before that, we have taught and introduced new team members, basic skills and strategies. And through the competitions, the off-season competitions, we were able to apply the newly learned skills of the new team members.
Okay, for our build season, we started off like any other team. We did our kickoff, and then we had our time of doing prototypes, and we worked with CAD very closely in order to create our robot. We made tons of prototypes. Our programming made our code from scratch, and they also tested our prototypes. And this last year, we tried to attempt the Limelight, but we weren't able to do it since we didn't have the expertise. However, this year we were able to do it, and it worked flawlessly during our autonomous time. This year we also used Falcon 500s, and it took us a while to use them since there were a lot of things that we had to double and triple check in order to get them working and make sure that they don't malfunction during the season.
Okay, so we were one of the fortunate teams that got to compete. So we were at Southfield week 1. So in Southfield, the kid with the arrow pointing at his head, he wrote an autonomous code in between matches with one of our mentors. That was pretty cool because by the time it was lunchtime, the autonomous code was already written. So we also, in between matches, we modified the robot, not just mechanical wise, but electrical wise as well.
Another problem we had was with the mechanical side. We had to modify the intake many times and just change it up a lot. We also, while we were fixing everything, our safety captain was making sure everything was okay and nobody got hurt, and her peers awarded her with the UL Safety Award.
So in the competition, we did very good. So we were captains of the 7th-seeded Alliance, and we got to the quarterfinals, obviously, but we didn't do as well. However, at the end, we did win the District Engineering Inspiration Award.
Hi, don't mean to interrupt, but you guys went over the 5-minute mark, and if you guys could just share one more aspect, we just want to make sure there's enough time for all teams.
Okay, so this is our last slide. We just want to thank all our sponsors.
Okay, thank you so much. So our next team will be 5943, the Bad News Gears.
Is anyone from team 5943 here?
Anyone from 5943? If not, then we will move on to 4909. You guys can present your screen.
Can you hear us all right?
Yes.
All right, cool.
Okay, so hi, my name is Avani. I am the team operations lead on Team 4909, as well as the co-captain of the team.
And I'm Jeffrey. I'm one of the robot co-leads of Team 4909.
So I'd like to start by introducing our team. So this is a team picture with all 30 members of ours, as well as all of our mentors. So we've had quite a few big changes starting this year. We got a new high school built, which means that we got a new shop and a lot of new spaces for the team to use and build, as well as a lot of new machinery. With this new high school, we also got a whole new grade. We added the 8th grade into our school. So all of our new members, except for one, so that would be 16 new members, are all from the 8th grade, which was a huge change for us, the team. And it took a lot of effort to kind of integrate them into this completely new environment, but it went pretty well, I would say. One of the big things that we've accomplished this year is kind of putting a lot more effort into community outreach and a lot of effort into fundraising. We made a business plan, which you can see on the left, as well as a teen demographics fact sheet, which you can see on the right. Both of these were showcased at all of our competitions. We also have a new pit setup. You can see some of our buttons, a new banner, and a lot of tools and much more space to keep organized. These are two of the fundraisers that we did. On the left is a restaurant fundraiser that we did at Panera, and on the right is a picture from us selling scratch tickets for our scratch ticket raffle. Earlier in the year, we also did a calendar raffle, which helped us raise a lot of money for the team. Another thing that we do is always prepare for awards. So this year we won the Safety Award and Engineering Design Awards. For the Safety Award, we made multiple quizzes for different aspects of safety, and we also compile a safety plan, and we prepared a lot of information for these awards for the competitions itself. This is our team with our very first blue banner at the end of our first competition. Unfortunately, our second one was obviously canceled due to the current situation, but we are so thankful that we got to compete at least one.
All right, so now we're going to move into the robot side of things. So this is 4909's robot this year, Mantis. It is designed to be a tall upper-level shooter that can shoot from far distances at multiple angles. So on to the next slide. Okay. So the drivetrain is a custom drivetrain with a custom gearbox with 4 Falcon 500s geared to run at 14 feet per second with 6 traction wheels on a drop center. So now we're going to go through the robot, if you look on the right picture from left to right, basically following the path of a ball. So the intake is a virtual 4-bar with actuation driven by chain and tube and intaking driven by polycord powering 4-inch compression wheels. After that, balls reach a funnel that orders the streams of balls into single file before delivering them to the indexer, which is powered, and this is powered by a Neo 550 and polycord. And then after that, we get to the indexer tower, which stores and delivers balls to the shooter using 2 photoelectric sensors that organize the balls and move them with polycord running on a Neo 550. After that, we get to one of the more complicated systems on the robot, the shooter. It's a hood shooter turret with a flywheel driven by 2 Falcon 500s. The hood angle actuation is done using a Johnson Electric liftgate motor on a rack and pinion system. And the entire thing is turreted with 360-degree rotation powered by a Neo 550 that aims using a limelight. Now, the climber is a bit of a special situation. The climber that we use for our competition is not in the CAD currently, as we may or may not have thrown it together the night before. But it is a spring-loaded telescoping set of aluminum pieces that deliver a hookup to the bar. The aluminum is held down with a winch mechanism powered by 2 Neo motors. And when lifting our robot, a ratchet and pull mechanism on the winch automatically engages to hold us up with an actuating servo motor. So if anyone wants to look at our CAD, it's all public. I believe it's public. Like everything from the past 4 years is public. We use Onshape. So you can look that up if you want to look at it. And so I believe next we have a video of our auto. Yeah, so our auto is a basic, we fire the 3 balls that we store and then back up off the line. Okay, so our design throughout the year changed a bit, especially once we attended a week 0 and we learned the weaknesses of our robot design. So initially we intended to build a Lobot to fit under the trench, but we quickly decided that focusing on making a very good tall shooter would be much more advantageous in the long run. Also, we initially wanted to implement a buddy climber, which you can see the remnants of on the back of the robot with that A-frame there. This would have lowered down after we climb and lifted another team up. Sadly, we weren't able to implement it before our first competition. So luckily, we were able to attend our first competition at the Granite State New England District event. We did very well at the event. We proved that our shooter was very accurate and could consistently hit outer port and often the inner port. And we also became, as you can see in the picture here, the first team at the event to complete a triple climb. Through the event, we became the third seed alliance we became the captain of the third seed alliance along with 501 the Power Knights and 7822 Generals Robotics. And we won the event to receive our first Blue Banner ever in team history. And then along with the awards that Avani mentioned earlier, also our Dean's List nominee, Matt Young, moved on to be a semifinalist.
These are all of our social medias, so if you would like to follow us and keep up to date, this is where you'll find us. Everything is at Team 4909. We also would like to thank you for taking the time to hear us talk about our team and our robot. You can find all of our blog posts, mentorship, pictures, social media, and everything else on our website, which is also at team4909.org.
Thank you so much. So before we move on to our next team, I just want teams to keep in mind the 5-minute time limit just because we want to get to every team. So we're sending every time a 30-second reminder. So with that said, it's 117 Steel Dragons will be the next team presenting.
Hi, can everyone hear me? Sorry.
Yes, you're good.
Okay. Yeah, so we're the Steel Dragons from Pittsburgh Alderdice High School. I'll walk you through quickly the business side of stuff, and then I'll have our build captain walk you through the technical side. So the number of students this year enrolled in the team has been steadily increasing over the past few years. This year we had 21 new members, so we increased our student enrollment from 14 to 35, which is really impressive. This year we also were able to ramp up our fundraising efforts and managed to raise twice the amount of funds as in previous years, so we were less strained throughout the season. This was also the first year we attended the second regional for the first time, which was the Miami Valley Regional in Ohio on week 1. And we're thankful for this because if we hadn't done it this year, we would not have been able to play a single match this year. So this was a good year to have that behind our belts. We also expanded our social media this year along with some other organizational tasks. And this is the first year we designated a social media team, and we're hoping to grow this in the future as well. I'd like to hand you over to Alex, who's our build captain, and he'll walk you through the technical side along with showing you some of our autonomous modes.
All right. So I'll start out by talking about our climber. So we had a cascading climber, which was we originally made it out of PVC pipe, and then we found that to be pretty unreliable during our first competition. So before our second competition, we were working on transitioning it to aluminum square tube. It was canceled. And then when the PVC extended, 2 hooks would detach after it hooked onto the bar, and we would winch ourselves up just using a Neo. Secondly, we have our conveyor mechanism, which we called the tube. So it was able to hold 5 power cells, and we used Polybelt to move them up along the to the shooter, and we had a beam brake sensor to ensure a smooth transition from the intake to the conveyor, and we also were able to actuate it, which another team member will talk about in a minute. And then finally, the shooter had 2 high grip wheels to shoot the balls using Neos to drive them, and we found that they were pretty unreliable during competition, so we were planning to add flywheels between competitions, but we didn't have the chance, and it was just positioned right at the end of the tube. So Ben, if you want to finish the.
Yeah, so our intake, actually, Aaron, if you can go back to the previous slide. Our intake was a big part of our robot this year. We iterated on that a lot. Our main focus was its rigidity and it not breaking throughout competition. So the whole intake was actually mounted on flexible 3D prints mounted directly to the frame, which we tested extensively by running the robot into walls repeatedly and seeing if it broke. And we actually got to the point where we could run the intake into the wall at full power and not break it, which was a big thing for us. And it had mechanism wheels on it that would vector the ball into the center. Yeah, and then also another big element of our robot was the fact that we could start with our tube mechanism pointing up, so we could be within frame perimeter, but then we could lower the whole thing down. It was held up by 2 gas springs on either side of it, and then a winch would pull it down, working against those gas springs, and that would allow us to go underneath the trench, which was really cool. It also allowed us to aim our shooter, and it kept the entire robot pretty simple mechanically, and we didn't have to have any complicated indexers that were shaped weirdly. And it let us build a robot that was within our abilities to build things. Yeah.
Okay, we have some videos of our autonomous. Aaron, if you want to go to those slides.
The audio is not very important, so you guys don't have to hear that. Yeah, so there you go. A lot of these changes were made in the interim between the Miami Valley Regional and what was going to be the Pittsburgh Regional, but now we have this sort of now period that we got to work on it, but didn't get to use it. But yeah, we're really proud of the changes we made and how the team grew this year. That's all we have.
Thank you so much. Okay, so our next team is 4188 Columbus Space Program.
Okay, so hi everyone. I'm Kevin. I am the Chief Operations Officer for Team 4188. And so we would like to introduce you to our robot. Next slide. Kyber. So starting a little bit with our robot. If any one of you other guys want to just lay down the basics of our robot.
Yeah, sure. So I'm Sean McGibbon. I'm the chief engineer for this year for 4188. Our robot, we wanted to focus on a tall design because we thought it would be a simplistic design for us to focus on the more important aspects like climbing and shooting. We weigh 124.5 pounds, just under that weight limit. We're 44.75 inches tall. We have a West Coast center drop drive with 6-inch pneumatic wheels, coding in Java. We have a limelight targeting, 360 turret, and a very quick 5-second climb. This is kind of the basics. We got a lot of store, so I'm going on the next slide, and Talata, you can take the drivetrain.
So just a little bit about our build season. On kickoff, what we do is we go ahead and split up our team into these things called IPTs, integrated process teams. And what happens is these subsystems will work on their part individually. And then at week 4, we integrate all of those different subsystems into one big robot. And we also use another process called 5S. This is one process that a lot of big scale companies use, like Toyota and Oneta. And what it is basically an organizational technique that you use to save money, to keep everything safe, and to reduce time waste.
So basically, just a quick rundown of the drivetrain. I'm Talata, and we have 6-inch Coulson wheels with a 1/8 setter drop. We used Falcon 500 with just a standard transmission to power the whole thing. Next slide.
I'm on next slide. Can you see it?
Everything is green.
Hold on, let me just try one thing. How about now?
It hasn't loaded in for me yet. If you can see it, okay, never mind. So for our intake, it's actuated with 2 pistons, and we use compliant wheels to intake the ball into the indexer system. And for the indexer, we used a lot of polycord and rollers so that we could properly handle the ball while we had it inside. And we used Omni wheels so that we could keep the balls moving within the indexer without having all that friction that comes with having other stationary wheels. And it has a 5-ball capacity.
So for our climber, we wanted to have something pretty simplistic because we knew in the beginning of the season that it was strategically important to be able to climb. We have a single stage elevator and powering our climb with a 5 to 7 second climb speed up and down. All the parts that are shown in this CAD model were actually designed and manufactured in-house with our own CNC router. It's 2 separate arms they're using for self-balance to straddle the middle of the bar to get that extra balance for 15 point extra. We have 2 Falcons powering each side. The gearbox ratio, I can't remember the actual ratio, but it is enough. 1 gearbox is enough to lift the whole robot. So it's a pretty powerful climber. And it's 2 arms for self-balance, but it can actually climb with just 1 arm in case of an emergency. And it also is fitted with 2 pneumatic brakes in order to keep it elevated after the buzzer has sounded. Our shooter is consistent of 2 Coulson wheels about 1.25 inches apart from each other. We found this was a pretty good spacing to kind of center the ball on our single, dual flywheel shooter. It has 2 angles. One is for anything in front of 8 feet, and then anything closer than 8 feet, we adjust to our close range shooter with those pneumatic pistons on the lower right. That allows us to shoot all the way up to the key. We can be right against the wall and still shoot into that outer port pretty well. We have a limelight for targeting. This, as well as aiming our turret, it also serves to find the distance from the front of our robot to the front of the power port. It is a 360 turret, so we can shoot from front and back. We can shoot from angles, and you'll see in a video later, we can actually shoot while we're climbed. So we'll see that in a little bit. And our max speed on our shooter is 6,000 RPM due to a direct pulley belt system from those two Falcons to our Coulson wheels.
So CSP has a number of different outreach programs from FLL to FTC. We do a lot of different things. Two of our oldest programs are Tech It Out and Robotics in the Classroom. Robotics in the Classroom takes each year's game and it turns it into physics and computer science problems that local schools use in their AP physics and computer science classes, while also being used by our drive team to help solve problems in the game. The Tech It Out Challenge actually happens at the Columbus District event. We host that every year, and it's a field trip for all the schools in our county. So students come and participate in the Tech It Out Challenge, which is a fun STEM-based activity for them to participate in while also getting to see the robots during the matches and games. Our safety manual, specifically battery spill kit procedures and CPR, are translated into 5 different languages. This is designed to allow it to where we can spread safety to everyone around us.
And adding one more thing with this one, if any of y'all would like to help with the translation of the safety manual, please contact us and we'd be happy to work with you. And then I guess we're gonna wrap it up. So we have been winning Chairman's Award. We won for our district last year. And you can go ahead and go to the next slide, Sean. We went to our competition this year at Gainesville, and we were lucky enough to go and compete. And we ended up ranking second, winning the event, and we got the Excellence in Engineering Award.
That's our auto right there, showing in the bottom right. We shoot the 3 balls we start with, and then go for the other ones. And this is just a few pictures of our robot, just very pretty powder coated, as well as our pit setup. We like to, for awards and organization. And one video that I'd like to show.
We can skip the videos.
Okay.
Yeah. So here's all of our social medias. We have all of our photos on there, all of our videos. Feel free to follow them. And I'll also put the links to them in the chat.
And that wraps it up for us.
Thank you so much. Okay, is anyone here from 1684? No one from 1684?
3566. Gone fishing. Okay, well, they didn't take photographs. That's okay. We're gonna move on to Team 67 Hot. So you guys can go ahead and present.
All right, can you guys hear me?
Yes.
All right, so we are Team 67 Heroes of Tomorrow from Milford, Michigan. We competed in a week 2 event that we hosted. We were the captains of the First Seed Alliance and we won the event. This is just a picture of our robot. Moving on to our electrical portion of our robot, we had 3 panels that were all mounted on the bottom of our robot. It made for an easy access when we flipped the robot over because our robot was packaged to where it would be hard to access it on the top. So we had 3 sections. Sophia, do you want to talk about programming?
Yeah, can you go to the next slide? Okay, so here's a programming overview real quick. Some of the highlights are our automated conveyor system that we used 5 sensors to control the ball being the staging system. Before shooting, we auto-aligned with a limelight. And then there were a variety of other features to just increase the driver operator experience, like the dashboard indicators and the LED system on the robot. And then for the Milford competition, we were running a 6-volt Auton under the trench. We were working on improving that and creating more options for our next competition before the season was cut off.
All right, so moving on to our drivetrain stuff. For the So moving on to the drivetrain stuff. For the drivetrain, we had 4 Falcons, 2 per side, and we used 5-inch Coulson wheels. We originally had 4-inch Coulson wheels, but we decided to swap to the 5-inch ones to make going through the rendezvous point easier for us. And we have 8 wheels for our drivetrain. For the intake, we decided to go with a full width intake. That way we could grab balls from pretty much anywhere the robot was facing. And we have a series of rollers that grab the ball and so that way we can make sure that the ball is ours before we start to vector it over towards our conveyor system. And whenever it gets over to our conveyor system, we found that there was a dead spot in that area. So we made what we call what we've basically just called the paint stir, which is a series of star wheels on a shaft that spin and push the ball into the conveyor system. And on top of the paint stir on the same shaft powered by the same motor and stuff is where we were going to put our Wheel of Fortune spinner, or the control panel spinner. But we ended up having to remove it at the competition because our robot was overweight. But the basic idea with it was we would have it sitting on that shaft, and the whole intake itself is mounted on a arm. So we would raise that to have the wheels on the control panel spinner contact the control panel itself and spin it. And then also the arm also helps us with aiming because our limelight is mounted within the arm, and it raises to various heights depending on where we're shooting from.
So coming from the intake, we store our power cells in the conveyor and candy cane. And so the straight section of the conveyor, as you can see on the side right here, contacts the power cells on the top and bottom, and it's driven by a bag motor into a versaplanetary gearbox, then to a set of 3D printed bevel gears. And the candy cane stores power cells in a 180-degree turnaround that's located at the very back of our robot. And it is driven by a 775 Pro into a versaplanetary gearbox and directly drives the exterior round belts. Power cells are staged into the candy cane and conveyor through the use of 6 beam brake sensors for optimal 5 power cell storage. Now, in actuality, we can store about 9 power cells to this robot using the intake as well as the candy cane and conveyor systems. Then moving on to the shooter, we have an indexer driven by a bag motor, and the indexer is actually a piece of hex stock, so that way we can time the how well when we want to feed power cells into the shooter. The shooter itself is made up of a set of 3 6-inch AndyMark high grip wheels, and it's driven by 2 Neos, which are bolted to the wheel shaft, and we can spin up to 6,000 rotations per minute. We change our shot trajectory angle with 2 pneumatics mounted on the shooter wall and hood, and our 4 shots that we can achieve with these 2 pneumatics in series are directly against the wall to score 1 robot behind the wall from the auto line and the trench. Then to climb, we have 2 3-stage telescoping climbers with constant force springs on them, and each climber is driven by a Falcon motor. And originally we had pneumatic ratchets in the gearboxes, but when we arrived at Milford, we were a little bit overweight, so those are one of the functions that got cut from the robot. Luckily, we didn't need it. The power from the Falcons into the gearbox was more than sufficient. And by having 2 independently driven telescoping climber arms, we can shift our center of gravity and balance on the bar. As you can see from this picture, our robot's a little turned, so that gives us the ability to balance the bar no matter where we climb. Anyone else have anything to add?
Yeah, just adding a little bit as to what our team's been doing after the season's been canceled. We've been participating in OnShape's design challenge, so that's a great way that our team's been staying together and still working with each other. And also, multiple of our students and mentors have been producing face shields and masks with their personal 3D printers at home to donate to hospitals and stuff, since we can't access our team 3D printers.
Great. Well, if anyone has any questions, feel free to reach out to us. Everyone on our team loves talking about our robot. I think that it's one thing that we're all really proud of, and thank you for the time to present this.
Perfect. Thank you so much, Team 67. Now, Team 1758, can you please present your screen and share?
There we go. Oh, can you go back one? Sarah Beth, are you here?
All right, yeah. All right, so we're Team 1758, the Technomancers.
I'm Jack, and Sarah Beth.
Yeah, I'm Sarah.
And so
we're from Florence, South Carolina, which is where the red dot is. So it's about like an hour and a half away from Myrtle Beach. Our rookie year was in 2005, and we are composed of the 3 high schools in our area, as well as homeschool students. And so we meet at our Career Center, which is kind of a neutral ground. So we don't meet at one high school to give any of them advantage. And we're made up of about 30 students and about 12 mentors.
So this is a prototype shooter that we made. It was pretty simple, made out of 8020. And so I used that to give context for our actual robot named Twin Fury based on, we basically took that prototype shooter and made it double as wide and out of more sturdy materials, not 8020, because that's really heavy and it has a tendency to rattle loose. And so this is our robot. Don't have too much written down here, but 4 Falcon drivetrain with the kit parts chassis. We tried to keep it as simple as possible. So the intake is within the bumpers, powered by 775 Pro. Then we have a feeder wheel powered by another 775 Pro and a Neo for the shooter wheel. We added a second one after our first competition, which we plan to use for Smoky Mountains. It worked a lot better. It was a lot more stable because the problem we had was running it at full speed. We need to run it at full speed in order to shoot from the target zone. And if we had any problems with the battery, if it was below full charge, it would not be able to get up to that speed. And so that was a problem we had. So we wanted to keep it simple, robust, and serviceable. And so that's why we focus on keeping it as simple as possible, shooting from the target zone. And we shot twice at once. It allowed us to keep it very simple in the indexing. We kind of made us give up on the 3-pointers because you couldn't aim as precisely. But we kind of realized early on that we weren't going to be getting those 3-pointers anyways. So it made a lot of the design challenges a lot simpler. And we plan on adding a climb for our second competition after we'd gotten everything working with the shooter. We wanted to live or die by that shooter, and that really worked well for us. Here's an auto video. Bottom right. So we had that 3-ball auto, worked most of the time. Sometimes you'd only get 2 in. And then shooter. Intake was very quick. And then a lot of teams had trouble lining up without automatic adjustments, but we just ran into the wall every time and it worked pretty well. And yeah, so we just kept it as simple as possible. There was something else I was wanting to say. Oh yeah, so we won Palmetto along with 694 and 4020. 694, the #1 seeded, picked 4020, who then proceeded to pick us in the in the second round. And so yeah, we were the only team in the playoffs at Palmetto without a climber, and that was a lot. We had a very good shooter because of that. We were ranked 11th with OPR, and 4020 said they had us ranked 13th for point contributions overall. So I think that was very impressive without having a climber. I think we would have done really well if we had been able to add that climber for Smoky Mountains, which we were working on for Smoky Mountains and championship since we qualified for the first time since 2008. So that we were really happy about that. So yeah. Sponsors and follow us on Instagram if you want to do that.
Perfect. Thank you so much, Team 1758. Now let's have Team 3322 share their screen. And then after they present, we're going to take a screenshot of everyone, and then we will be open to questions.
All right, hello everyone. I'm from Team 3322. I'm gonna share my screen real quick. So we'll start it off with the reveal video. We were fortunate enough to have competed at the category #1 competition in Michigan, and we ranked 2, and we actually had the 3rd highest teleop score in Michigan after that first week. So we were really proud of our performance there, and it's the best we have done since 2012. So here's our reveal video. All right, so here is our technical binder. I'm gonna briefly go through some of the cool features we have, and I'll drop the link into the comments if you guys want to take a closer look at it. So this year we really focused on integration, because last year we had way too many separate systems and our overall robot was way too heavy. So we focused a lot about integrating our systems this year. And a lot about prototyping even before the season started. We actually predicted this year would be a shooter game, and a couple of our designers worked on prototyping a shooter before the season even started. So that sort of contributed to our success this year. So our intake, feeder, and hopper systems all work really well together. We use Polybelt, and we at all points we have contact on the ball, so to prevent jams. And that was really well. That worked really well for us at competition, because we found out in our earlier testing stages that these balls were really sticky, and we wanted to avoid jams at all costs. So if you guys want to read more about it closely, I'll drop the link as stated. Our shooter is a hooded backspin shooter with two Neos, and our climber is just a telescoping climber with a detachable hook. And our hook is actually, we spent a lot of time on the hook. Since we only had one point of contact, we didn't want our hook to swing around and fall. So we have this crescent right here to lock onto the pole and prevent us from dropping out. So I'm gonna hand it off to our programmer right now, and he can talk more about programming. Alex, are you there? Okay, we're having some difficulties. Okay, his audio is not working. So
It said mic is working. Audio is probably not working.
I think we can hear you, Alex.
Can you hear me?
Yeah, we can hear you.
Okay. Push the ball backwards, allowing us to store 2 balls in the feeder and 3 balls in the hopper. This not only made sure that we wouldn't have balls jamming, for example, at the intake or when trying to go into the shooter, but this also ensured that we could guaranteed have 5 balls stored to maximize the amount of points we could get per cycle. Additionally, as reveal video, we have a 6-ball autonomous. We developed that at the end So we were prepared no matter what.
There's an issue with the audio.
Yeah, we can't hear Alex. Could maybe Kevin present because we can't hear Alex?
Okay, sure. I can probably take over and try to fill in some stuff. So from our reveal video, we have a 6-ball autonomous. We were going to use that for our second competition, which would have been at Lansing, but unfortunately things changed. So we use Limelight, and I'm not a programmer, so my information will probably be a little bit sparse, but I will add the technical binder into the chat if you guys want to take a look. But we had a lot of early testing. We finished the first prototype of a shooter really early, and we gave the programmers plenty of time to test, and that also contributed to our success. We also, some cool features is we have a proximity sensor attached to the bottom of the hopper for additional sensing. So I guess that's it for our presentation. And yeah.
Perfect. Okay, thanks so much. So now we're gonna go ahead and we're gonna take a screenshot of everyone. So if everyone could turn on their cameras for a sec and just give me a minute because there's like multiple screens, so to take pictures of them. Okay, I'm gonna give everyone a minute. It's loading. Perfect. Thank you so much, Kevin, for sending the technical binder. Okay. Okay, perfect. So that's it. We put in the chat, I just put in the chat a link with a feedback link. If you guys could fill that out, it'd be great. It's a quick form. It shouldn't take more than 5 minutes. Also, let's stay here. Let me show my screen. Thank you everyone so much for attending. Let's be in touch. Make sure to follow us on Instagram, Facebook, and our emails there. Also our GitHub, we share a code on there. And yeah, make sure if you take any stories to tag us. Yes. So now we're gonna go on to questions. So thank you everyone for being patient and waiting. So if anyone has any questions, you can't open that form. Oh, sorry. Okay, we'll fix the form. So if anyone has any questions, please write them in the chat and then we'll read them out loud and then we'll address it to each team.
And while we're waiting for questions, I just want to, again, thank everybody for coming. It was great to hear from all of you, to see all the presentations. I apologize for rushing through some of them. I mean, we're already at 2 hours here. You know, we had nearly 20 teams to present, and we obviously wanted to, you know, give everybody a shot. So again, I want to thank you guys a lot for coming. And yeah, just if you want to post any questions in the chat.
Email us your presentation so we can just.
While nobody is asking questions yet, 1836 is also participating in OnShape's Robots to the Rescue challenge. And so if anybody wants an alliance, 1836 also has been using OnShape for a couple of years. So if anyone needs any help for OnShape or anything like that, feel free to ask for help from us. We're happy to do it.
Good time to plug also the MKCAD that we run, that our alumni started, that we continue to update. I believe, Mikey, that you contribute to that as well. So that's a really good resource.
The form should be up and working right now. So if you guys can try again and let me know, that'd be great. Perfect. Thank you so much for coming and everyone for attending. Make sure to tag us on social media and email us your presentations and let us know if you have any questions. So I think that's it. I'm going to drop into the chat the links. And yeah, thank you.
Thank you.
Thank you.
Thanks for hosting.
Thanks for hosting.
Thanks.
Bye. Thank you. If you're not on 1836, could you please leave the meeting? Okay. You guys can go off mute now. Hello?
Abby, did you stop the live stream in the?
Yeah.
Yeah, and you can stop the recording as well.
Oh gosh.
That was really good. I just forwarded an email to you for